Good morning, everyone. Welcome to our presentation on accident prevention using ESP32 and sensors. Today, we'll be discussing a vehicle-to-vehicle communication system that aims to enhance road safety. My name is Shreyas Lal, and I'm here with my talented team members Noel Alias, Abhidev Raj, Avanthika Riji, and Sivapriya CS together. We'll walk you through how our system works, the technology behind it, and its potential impact. So, let's get started and explore how innovation can make driving safer for everyone. Vehicle-to-vehicle, or V2V communication, is all about cars talking to each other wirelessly. They exchange information like speed, position, and how far apart they are. This kind of communication helps cars understand their surroundings better and can even prevent accidents before they happen. For example, if a car detects a potential collision or a blind spot, it can alert the driver in real time. It's especially useful around turns or in tricky spots where visibility is limited. By sharing this information quickly and reliably, V2V technology enhances safety and keeps us all safer on the road. This is a key part of the broader connected vehicle ecosystem we're exploring today. Today, I want to talk about designing a low-cost prototype that can really showcase how two vehicles can communicate effectively to avoid collisions. The core idea here is to create a system where vehicles can sense each other's proximity. So, basically, how close they are to one another, and then send alerts if they get too close. This approach is all about demonstrating a practical, cost-efficient solution that enhances safety on the road. By focusing on this prototype, we aim to highlight the importance of communication between vehicles and how simple sensors and alert mechanisms can make a big difference. This ties into our overall goal of improving vehicle safety through innovative, accessible technology. All right, let's take a closer look at the key components required for this project. First up, we have the ESP32 microcontroller, which is central to our system. It's Wi-Fi and Bluetooth enabled, meaning it can connect wirelessly to other devices or networks, making our project more versatile and smart. Next, we have the ultrasonic sensor, specifically the HCSR04. This sensor is crucial because it allows us to measure distances accurately, which is essential for many applications like object detection or obstacle avoidance. Then there's the LCD display, a 16 by 2 character screen. This will serve as our user interface, providing real-time feedback, status updates, or other important information right on the device. We also include a buzzer module, which adds an auditory alert component, useful for notifications or warnings. LED indicators are part of the setup as well, giving visual signals for different statuses or alerts, making it easier to monitor the system at a glance. For powering everything, we have a power supply, which can be either a battery or a USB connection, offering flexibility depending on whether the device is portable or stationary. Finally, we need connecting wires and a breadboard. These are essential for making all the electrical connections in a flexible, easy-to-modify way, which is perfect during development and testing phases. All these components work together to create a connected, interactive system that can sense its environment, communicate wirelessly, and provide clear feedback, key elements that tie into the overall theme of building intelligent, autonomous devices. Now, let's take a closer look at how our demo model works. Each vehicle in the system is equipped with an ESP32 and an ultrasonic sensor. The ultrasonic sensor's job is to measure the distance between vehicles, giving us real-time data on how close they are to each other. When the measured distance drops below a predefined safety limit, the ESP32 immediately triggers an alarm, which includes both a buzzer and an LED indicator. This instant alert helps prevent potential collisions by warning the driver or system operator. Additionally, the data collected by each ESP32 isn't kept isolated. Instead, it's shared wirelessly between the boards, creating a networked awareness across the vehicles. This sharing of information ensures that all units are informed about the current situation. Finally, the LCD display plays a crucial role by showing real-time distance measurements and warning messages. This visual feedback makes it easy to monitor the system's status at a glance, reinforcing how integrated and responsive our safety mechanism is. Together, these components demonstrate a practical, effective approach to vehicle safety and collision prevention, reflecting the core theme of our presentation. On this slide, I want to walk you through how these advanced vehicle systems work in real life. First, each vehicle communicates with others through a V2V wireless network. This means cars are constantly sharing information with each other, creating a kind of connected ecosystem on the road. Next, these vehicles use a combination of GPS, LiDAR, and other advanced sensors to accurately detect their surroundings. This helps the system identify nearby vehicles, obstacles, and potential hazards with high precision. Real-time alerts play a crucial role here. They warn drivers about nearby vehicles or risks like blind turns, giving them enough time to react and avoid accidents. Additionally, the system integrates with traffic data and vehicle control systems, enhancing overall traffic management and safety. Ultimately, all of these components work together to help prevent collisions and promote smoother traffic flow, making driving safer and more efficient for everyone. Sure, here's the word-by-word narrative script for Slide 7. Today, I'll be explaining the role of ESP32 in our project. First, the ESP32 acts as the central microcontroller, meaning it's the brain that coordinates all the functions. It reads distance data from sensors, gathering real-time information about the environment. Then, it processes this data through its logic to determine if there's any risk present. Essentially, it assesses whether safety thresholds are being exceeded. Next, it communicates wirelessly via Wi-Fi or Bluetooth, sending and receiving signals to other devices or systems as needed. It also displays important information on an LCD screen, keeping users informed at a glance. And finally, the ESP32 can trigger alarms if it detects a potential hazard, ensuring quick responses. Overall, this role is crucial because it connects sensing, processing, and communication seamlessly, making our systems smart and responsive. Now, let's talk about how the ultrasonic sensor functions. The HCSR04 sensor works by emitting sound waves and then measuring the reflection time. Essentially, it sends out a pulse of sound and waits for it to bounce back after hitting an object, like another vehicle. By calculating how long it takes for the echo to return, it can determine the distance between vehicles very accurately. This distance measurement is crucial for our system, because if it detects that the gap between vehicles becomes too short, it sends a signal directly to the ESP32. This helps in alerting or controlling the vehicle to maintain a safe distance. What's impressive about this ultrasonic sensor is that it works effectively even in challenging conditions, such as in blind turns or in poor visibility scenarios. So, regardless of the environment, it can reliably provide critical distance data. Overall, this ultrasonic sensor plays a vital role in enhancing vehicle safety by continuously monitoring and responding to the proximity of other vehicles. On this slide, I want to highlight how our system provides clear and immediate information to the driver. The LCD, which is a 16:2 display, shows the vehicle's current distance to the object ahead, as well as any warnings that might be necessary. This makes it easy for the driver to stay informed at a glance. In addition to the display, we have a buzzer and LEDs that serve as real-time alerts. These give an immediate, audible, and visual indication if the safety distance is breached, helping the driver react quickly. Importantly, these alerts only activate when the safety distance is actually compromised. This prevents unnecessary disruptions, especially in situations like stationary traffic. We've integrated smart logic into the system so that false alarms are avoided during such conditions. Overall, this combination of visual and auditory cues ensures the driver is always aware of their proximity to other vehicles, enhancing safety without causing distractions. Now, let's talk about why implementing this technology is so important. First, it significantly reduces road accidents by providing early warning systems that alert drivers to potential hazards before it's too late. This proactive approach can truly save lives. Next, it enhances safety, especially in tricky situations like blind turns and areas with heavy traffic, where visibility is limited and the risk of collisions is higher. By supporting these challenging driving conditions, we make roads safer for everyone. This technology also plays a crucial role in advancing smart transportation and autonomous driving. It helps vehicles communicate better with their environment, paving the way for more reliable and efficient self-driving cars. Another key point is that this is a cost-effective and scalable solution. It can be adapted to various contexts and expanded as needed, making it accessible for many communities and transportation systems. Finally, all these efforts contribute to the Vision Zero goal, aiming for zero road fatalities. Implementing this technology is a vital step toward safer roads and saving lives everywhere. And that brings us to the vehicle-to-vehicle communication system. Essentially, this system shows how advanced technology can make our roads much safer. By using devices like the ESP32 and various sensors, vehicles can actually talk to each other, sharing important data in real time. This communication helps prevent collisions before they happen, making driving safer for everyone. It's a great example of how smarter, connected vehicles can lead to safer roads overall. This ties into our overall theme of leveraging technology to enhance transportation safety and efficiency.